Hey, today we will be starting our last chapter of the year. Crazy that we're already getting into this last chapter, but we're going to be working a lot with quadratic functions in this chapter, which really will get you prepared for when you move up into Algebra 2 in a couple years. And we kind of got a little bit of background on these quadratic functions and quadratic equations in the last chapter with factoring, and in one of the lessons I gave you a little bit of context of how we would be using it moving forward, and today we will be using some of that. So we're actually going to be doing two lessons today, 9.1 and 9.2. 9.1 is on graphing quadratic functions. It's going to be a pretty quick lesson here. Then the next one, 9.2, is going to be on solving the quadratic equations by graphing. So we need to be able to graph them first. So let's go ahead and get into this. First off, we have a quadratic function, which is written in the form ax squared plus bx plus c, where a does not equal 0. Now, the reason a can't equal 0 is because then it would get rid of our x squared value, and it would no longer be a quadratic function. It would then be a linear function. A parabola is the graph of a quadratic function. A minimum is the lowest point of a parabola that opens upward. So if we had a parabola with a minimum, it would look something like this, where we've got this parabola graphed. Parabola is that curved line, and the minimum is the lowest point of a parabola that opens upward. So this parabola opens up. The minimum would be that lowest point on the parabola. Then our next word is maximum. The maximum is going to be the highest point of a parabola that opens downward. So here, if we have a parabola that opens down, that will have a maximum point. The vertex is the maximum or minimum point, so that very middle point. Then the axis of symmetry is the line that divides a parabola into two halves. They are mirror images of each other. The axis of symmetry will always be a vertical line that goes right through that vertex, or the maximum or minimum point. So the axis of symmetry is that green dotted line that I drew in there. Now again, they're mirror images of each other. My pictures here don't really show that. These aren't mirror images, but that's just a quick sketch. Now, one last thing. Parabolas will always be either positive or negative. A positive parabola will always open up. A negative parabola will always open down. You can think of it as a positive parabola is smiling. Positive is smiling. Negative is frowning. And you can always tell right off the bat whether it's going to be positive or negative, whether it's going to open up or down, based on looking at that leading term, the x squared term in your function, and seeing if that term is positive or negative. So let's go ahead and do a couple examples of graphing quadratic functions. Now, there's 4 steps that you're always going to follow in order to graph a quadratic function, and you need to do in this order. So the first step is to find the equation of the axis of symmetry using the following equation. Now, one thing I forgot to put in here, it should be x equals negative b over 2a. So again, our standard form, ax squared plus bx plus c, you're using your a and b terms here. Next, find the coordinates of the vertex by plugging the value for the axis of symmetry in for your x value in the original equation, and whatever you get as your output will be your y value of your vertex. Step 3, identify whether the vertex is a maximum or minimum. Does the parabola open up or down? And again, you tell that by seeing if the leading term is positive or negative. Step 4, graph the function, and remember the graph is mirrored on each side of the axis of symmetry. So let's go ahead and follow these steps in order to graph our function, negative 3x squared minus 6x plus 4. So again, first step is always going to be to find the equation of the axis of symmetry. So first thing I want to do here, sorry, board's not working. Here we go. So again, the first thing I want to do is always that x equals negative b over 2a. So really, you're finding b over 2a and then finding the negative or the opposite of that. Now in this case, our b value is negative 6. You always want to look at the sign in front of that value. And our a value is negative 3. So for this one, it's going to be x equals negative. Then in parentheses, I'm going to put b, which is negative 6, over 2 times a, so 2 times negative 3. So that will then equal negative, in my parentheses, negative 6 divided by negative 6 is 1. So negative 1. So my axis of symmetry is going to be at x equals negative 1. So I'm going to go ahead and draw that axis of symmetry in by just putting a dotted line at x equals negative 1. Remember, that's always going to be a vertical line. Next, step 2 is to find the coordinates of the vertex. In order to do that, I'm going to take that x value that I just found, and I'm going to plug it into my original equation. So I'm going to say f of x is equal to negative 3 times negative 1 squared minus 6 times negative 1 plus 4. Now, negative 1 squared is positive 1 times negative 3 will give me negative 3. Negative 6 times negative 1 gives me a positive 6 plus 4. So negative 3 plus 6 is 3 plus 4 is 7. And that will be the y value of our vertex. So now we've got the x value and the y value. So our vertex will be at negative 1, 7. So negative 1, 1, 2, 3, 4, 5, 6, 7. So step 1, we found that axis of symmetry. Step 2, we found our vertex. Step 3, we want to determine, is this going to open up or down? This one, since it has a negative 3x squared, means that this will open down. So then the last thing we need to do is go ahead and graph our parabola. In order to do that, I'm going to set up a table of values. And on this one, I'm going to walk through the entire thing. On the next one, I'm going to show you a little bit of a shortcut. So if you're going to graph the entire thing, you want to go ahead and put your vertex in the middle. So I'm going to go ahead and put my negative 1, 7 in the middle there. And I'm going to go, you always want to go 2 or 3 points to the left and to the right. For this one, I'm going to go ahead and go 2 to the left and 2 to the right. So for my x values, 2 to the left would be negative 2 and negative 3. 2 to the right would be 0 and 1. Then I need to go through and plug each of these values in for x in my original equation to come up with the y value for that point. So if I plug negative 3 in, that is going to give me, let's see, negative 3 times negative 3 squared minus 6 times negative 3 plus 4. So negative 3 squared is 9, so I would have negative 3 times 9, which is negative 27, minus negative 18 plus 4. So negative 27, this would be plus 18, would give me negative 9, plus 4 would give me negative 5. So I'd have a point at -3, -5. If I plug in -2, let's see, -3 times -2 squared minus 6 times -2 plus 4. So -2 squared would be 4 times -3 is -12 minus -12 plus 4. So in this case, that would give me -12 plus 12 is 0 plus 4 equals 4. And if I plug in 0, I'm going to get 0 minus 0 plus 4 is 4. If I plug in 1, 1 squared is 1, so I'm going to have -3 minus 6, which is -9, plus 4, which is -5. So now we're going to go ahead and graph those points, -3, -5, -2, whoops, sorry, -3, -5. 1, 2, 3, 1, 2, 3, 4, 5. -2, 1, 2, 3, 4, 0, 4, and 1, -5. So again, to make sure you did it right, you want those points to be mirrored on either side of the axis of symmetry. And then we're going to go ahead and connect our points with the parabola there, and that would be our graphed solution of this. So now we're going to walk through one more of these, but again, I'm going to show you a little bit of a shortcut when we get to that last step there. So I'm going to walk through this one a little quicker. First step, axis of symmetry, so negative b, which is -4, over 2 times a, so 2 times 2, would give me negative, let's see, this would be -4 divided by 4, which is -1. -1 is 1. So axis of symmetry is at x equals 1. Next, find my vertex. I'm going to plug this x equals 1 into my original equation. So 2 times 1 squared minus 4 times 1 minus 5 would be 2 minus 4 minus 5, which would give me -7. So my y value is going to be at -7. So my vertex for this one will be at the point 1, -7. Then we want to determine, does this open up or down? Since it's a positive function, it will open up. Now we want to go ahead and make our table to graph it. So this is where, instead of having to do 2 points to the left of your vertex and 2 points to the right, you can go ahead and just do one or the other. So I'm going to go ahead and just do my 2 points to the right on this one. So that will be, since I already have my point at x equals 1, I'm going to find my points for x equals 2 and x equals 3. So in this case, when x equals 2, I will have 2 times 2 squared minus 4 times 2 minus 5. So 2 squared is 4 times 2 gives me 8 minus 4 times 2, which is 8 minus 5 will give me -5. And then when I plug 3 in, 2 times 3 squared minus 4 times 3 minus 5 will be 9 times 2, which is 18, minus 12 minus 5, which gives me 6 minus 5, which is 1. So now I'm going to go ahead and graph those 2 points, 2, -5, and 3, 1. And 3, 1. And then I can go ahead and just mirror those to the other side of my axis of symmetry. So 1 point over means I'll have a point there, And then if I go one more over and go up to that same y value, that'll give me my parabola for that problem. So that's graphing quadratic functions. Next, we're going to get into solving quadratic equations by graphing. So in order to do this, first couple vocab words. Roots are the solutions of a quadratic equation. Zeros are the x-intercepts of the graph of a quadratic equation. So here, these two terms are actually used interchangeably. So roots and zeros are really the same thing. Then a double root is when two roots of a quadratic equation are the same number. So let's go ahead and get into some examples here. Solve by graphing. X squared plus 6x minus 7. So we want to go ahead and follow those same rules of graphing a quadratic function. First, find that axis of symmetry. So x equals negative b, which is 6, over 2a, so 2 times 1, which would be 6 divided by 2, so 3. So axis of symmetry at x equals negative 3. Next, find our vertex by plugging negative 3 into the original. So this would give me 9 plus negative 18 minus 7, which gives me, let's see, 9 plus negative 18 is negative 9 minus 7 would be negative 16. So that means my vertex is going to be at negative 3, negative 16. Now on my graph here, I don't have 16 going down, so for my y vertex, I'm going to go ahead and go by 2's. So my vertex would be negative 3, negative 2, 4, 6, 8, 10, 12, 14, 16. Vertex is right there. Now I'm going to go ahead and make my table to graph this. Now I'm going to go ahead and go 2 to the right. So I'm going to use negative 2 and negative 1. Now here, I need to go ahead and graph this, but I need to make sure that I get to the point that my graph will cross the x-axis. So if I plug in negative 2, it's my original equation, negative 2 squared plus 6 times negative 2 minus 7 will give me 4 minus 12 minus 7, which is negative 8 minus 7, negative 15. Then I'm going to have negative 1, so negative 1 squared plus 6 times negative 1 minus 7. That'll give me 1 minus 6 minus 7, which is negative 12. So I haven't gotten to the point that my graph is crossing my x-axis yet. So I need to do another one. If I plug in 0, 0 squared plus 6 times 0 minus 7 would give me negative 7. So I'm getting closer to that 0 value for y, but I'm still not quite there. So I need to keep going. Here I'm going to have 1 plus 6 minus 7, which gives me that 0 value that I need. So I know I'm going to have an x-intercept or a solution at 1, 0. It's going to cross the x-axis at 1. Then in order to figure out where it's going to cross the x-axis over here, on this one it's 1, 2, 3, 4 units from the axis of symmetry. So 1, 2, 3, 4 units from the axis of symmetry. Sorry, board is freaking out here. So again, 1, 2, 3, 4 units from the axis of symmetry. meaning my parabola would look something like that, and I would have solutions. Since they asked for the solutions here, we would give the 2 points where it crosses the x-axis, which would be at x equals -7 and x equals 1. Now let's do this one here. In order to start, I need everything set equal to 0, so I need to add my 4 to both sides, which gives me b squared plus 4b, plus 4 equals 0. And then follow my same steps. Axis of symmetry, x equals negative b, which is 4, over 2 times a, which is 1. Negative 4 divided by 2 is 2, so my axis of symmetry will be at x equals -2. So on this one, now I need to find my vertex by plugging that -2 into my original right there. So -2 squared plus 4 times -2 plus 4 equals 0. So this will be 4 minus 8 plus 4 equals 0. Or sorry, I'm not setting it equal to 0 here. 4 minus 8 is -4 plus 4 is 0. So my y value of my vertex would be at 0. So my vertex is right at this point, -2, 0. Now here, we see that our vertex is right on the x-axis. If we look to tell whether this opens up or down, we know this is going to open up. So it's going to look something like this. I don't have to do my table to graph any more of this because I already have the only solution I'm going to have. My solution for this one would be that x equals -2. Now technically, because the highest power is squared, technically we should have 2 solutions to this function, but this is that vocab word that we talked about on the last slide. This is called a double root. Technically, there's only one answer here. It only touches the x-axis once, but since there has to be 2 solutions, we would say that there is a double root. There are 2 solutions at x equals -2. So we went over a normal one of finding those x-intercepts. We went over a double root. Now this one is going to be another special situation that we can run into. Now here, same thing. Start with axis of symmetry. So x equals negative b, which is -3, over 2 times a, which would be 2 times 1. So it would be -3 over 2, which would give us +3 over 2. So axis of symmetry is at x equals 3 over 2, which is 1.5. Now we find our vertex by plugging that 3 over 2 back in. So if we go 3 over 2 squared minus 3 times 3 over 2 plus 4. When you square a fraction, remember you square the numerator and denominator, so this would become 9 over 4 minus, multiplying a whole number and a fraction, you just multiply the whole number by the numerator. So that would become 9 over 2 plus 4. If we do 9 over 4 minus 9 over 2, we need to give everything common denominators here. So a common denominator of 4, we'd have 9 over 4 minus 18 over 4 plus 16 over 4 would give us, let's see, 9 minus 18 is -9, plus 16 would give us 7. So our vertex would be at 3 over 2, 7 over 4. Now 7 over 4 is 1 3/4. So if I go up 1 3/4 there, that would be my vertex. Now again, this is why you always want to check here to make sure, is this going to open up or down? It's a positive, meaning it's going to open up. So if I think about this, I've got my vertex here. My parabola is going to open up. So here again, I don't even have to do a table to come up with my values for my graph. Because my vertex is here and it opens up, it will never cross the x-axis. So that means there is no real solution. Now the reason we say no real solution instead of no solution, once you get into Algebra 2, we start working with imaginary numbers. There will be a solution we can find to this, but we're not going to do that right now. We're only working with real numbers right now. All right, couple more things. Hang with me here. Next one, solving by factoring. So this is what we did in that last chapter, moving forward. So use factoring to determine how many times the graph of this function intersects the x-axis, and then determine the roots. So in order to solve this by factoring, we just want to take this polynomial and factor it like we did in that last chapter. So again, we can draw in our x. The top is a times c, 1 times negative 12. The bottom is b, which is 1. So we need two numbers that multiply to negative 12 and add to 1. That will be 4 and negative 3. So this factors to x plus 4 times x minus 3. We set each of those equal to 0. And then solve, so we would get x equals negative 4 and x equals 3. So determine how many times the graph will intersect the x-axis. It intersects 2 times. And then identify each root. Those are those solutions we just came up with. So really, this is what we did that last chapter. We factored in order to find those roots. What we were doing on that last slide then is graphing to find those 2 roots. Let's do one more of these. Here we need 2 numbers that multiply to 25 and add to negative 10. We know they're both going to be negative numbers. It's going to be negative 5 and negative 5. If we would have taken those steps we talked about in the last chapter for factoring and checked to see if this was a perfect square trinomial, we would have found that it was, because the first one is a perfect square, last term is a perfect square. Take the square roots of each, multiply them, and then multiply it by 2, and we get our middle term. So this comes out to x minus 5 squared. So in order to find our solution, set it equal to 0. So we would say that this crosses through the x-axis 1 time at x equals 5. Now if you had one that you couldn't factor, if it was a prime polynomial, then that would mean that it would not cross the x-axis at all. All right, last thing here. Rational roots. So when graphing to solve a quadratic equation, if integral roots can't be found, integral roots means that it's going to fall on a whole number or an integer. Then we're going to estimate the roots by stating the consecutive integers between which the roots lie. So this means that when we graph it, we're not actually going to have an integer for a solution. So I'm going to show you what we would need to do if that's the case. We're going to graph it the same way we have been. Axis of symmetry, negative b over 2a would give us negative 6 over 2, which is 3. So axis of symmetry at x equals negative 3. Find our vertex by plugging -3 back in. So -3 squared plus 6 times -3 plus 7 equals 0. 9 plus -18 plus 7 equals 0. Give us -9 plus 7, which is -2. Oops, sorry. We're not actually setting these equal to 0. We're finding that y value. So our vertex here will be at -3, -2. We know that it's going to open up, so we are going to have real solutions here. So let's go ahead and set up our table. I'm going to do my 2 points to the right, so I'm going to use -2 and -1. Now, if I plug those into my original, -2 squared plus 6 times -2 plus 7, -2 squared, since it's negative times a negative, that's going to give us a positive. Board stopped working again. Come on, board. So we'll get 4 plus -12 plus 7, which is going to give us -1. So we know we'll have a point at -2, -1. Then if we plug -1 into our equation, -1 squared plus 6 times -1 plus 7. It's going to give us 1 plus -6 plus 7, which 1 plus -6 is going to give us -5 plus 7 gives us 2. So we're going to have a point at -1, 2. So we see here our graph crosses the x-axis, but again, it doesn't cross right at a whole number. It crosses between two numbers, and then we can mirror those points on the other side of our axis of symmetry. So we've got our parabola there. So for this one, in order to give our solution, we don't have that integer or that whole number to give our solution in. So we would say that our solutions are between certain integers. So in this case, it would be between -4 and -5, and between -2 and -1. So that's just another special situation of how you can find the solutions there. So again, 2 lessons here. They're both going to be short homework assignments compared to normal, since the graphing is a lot of steps, and the 2 lessons together are pretty similar. In order to be able to do the second lesson, you need to understand how to graph that we learned in the first lesson. But those are going to be your 2 assignments. They're due on Tuesday. Again, just make sure you're getting them onto Google Classroom when you're turning them in, and feel free to be reaching out and asking me any questions you might have.